Hi, welcome to Get In, the connected vehicle podcast from BlackBerry. I'm your host, Steve Kovsky, and in this series, we'll be diving into what the future of transportation just might look like. Today, I'm very happy to be joined by one of our partners and guests on the show, and I'd like Bhaskar to introduce himself, if you would.
Thanks, Steve. Happy to be here. My name is Bhaskar Dani. I am with KPIT Technologies, which is a leading software solution provider and integrator for the automotive industry. I've been with KPIT for 18 years now, and I've been in a role where I've led primarily our automotive infotainment, connected vehicle, and outside technologies coming into the car, running in a variety of field roles. So happy to be here and looking forward to our discussion today.
Bhaskar, and you're there in the Detroit area in the heart of North America's auto row. I'm interested in starting out with what your experience has been with cars and with transportation. If you can think back to when you first got behind the wheel of a car and how that has changed to today, I'd like to get a little bit of your perspective.
Sure. So I grew up in India, which is primarily a two-wheeler place, and I got actually on a bike before I got behind a wheel. In the days, today India has the latest and greatest cars and features and all that, but at the time there were basically one of two cars that you could buy. There was a Fiat and there was an Ambassador, and both are today highly iconic, nostalgic brands. Both are discontinued, but from Bollywood stars to Bombay taxis, if you wanted a car, you had to get one of them, and also government officers. So my family had the Fiat, and that's where I learned driving on Indian roads. It was a very interesting experience. The stick shift was on the side of the steering wheel. There's no power steering, no power windows. No car radios, no AC. But driving was fun, and we basically got in the car for the experience of just driving. Over time, as my education career progressed, I came to the US to study and, settled here. I went through that curve of, value for money cars, then family cars. Then I thought I had one exciting car. Then a dog-friendly car, and this year my daughter will start driving. So I'm probably going to be in a market for a highly safety-fortified electric car just in about a year. So it's been an interesting journey, and it's purely a stroke of luck that my profession ended up in the same industry. So like I said earlier, with my role in infotainment and car radios, I got to see the whole movie from single line LCD displays to display audio to projection mode to today connected services and software defined vehicles. So it's been very interesting relationship with the car industry.
So one of the trends that you're really at the forefront of is, I think, personalization, because you're creating systems that the user is going to interact with directly. These are not embedded somewhere in the function of the automobile where they might not be aware of it. They're actually going to be controlling this, and it's going to be something that can help sell the car, can certainly differentiate the automobile. What are some of the trends and the challenges that you're facing in this age of personalized transportation?
Well, you bring up a very interesting point. Essentially, car makers have tried to personalize cars for a while now, and from the features and functions that touch the customer directly, interaction and, nowadays voice, there is even more demand for even more personal, feature pack for that particular car, but not just the car, but also the user, the occupant, and, what driver profiles are there. And actually, it is this trend that has now reached, its hype or, peak, that is driving the most fundamental change in the industry today from a software architecture standpoint. Consumers want their cars to be latest and greatest, up to date at the point of purchase, and that's a fair expectation. But what's now changing is they also want those cars to remain up to date over the life of the cycle. And what by that it means, as their personal, to your point on personalization, as their personal digital lifestyle changes and evolves with, technology trends, and, initially we had content and apps and then favorite music. Now it's, a lot more preferred, devices and features that are coming in. They want the car experience to be consistent with that and continuous with that. And that is leading to tremendous proliferation in the amount of software variations or variants that you would launch. And the traditional software development systems and methodologies that were being used by car makers, they cannot address that problem fast enough. They cannot catch up. And so that has led to this whole initiative in the industry for what we are now calling software defined vehicle, which is fundamentally re-architect the car as a platform and not as a fixed feature set that remains monolithic for 10 years or, over the life of the car. And to be able to build a platform like that, there's a fundamental change that is happening in the core architectural foundation of the car, software architecture foundation, ability to add, adaptability and portability to the data and the applications, and all of it leading to, almost like I said, a menu card of features that customers can pick, add and subtract over the life of over the ownership of the vehicle, not just at the point of purchase. So yeah, it's very interesting question you asked, and it's actually leading to one of the most fundamental changes in the industry.
This is a good point to talk a little bit about KPIT. And some of the listeners may not be familiar with the food chain of how cars come to market and the role of the original equipment manufacturers and then the rest of the community that takes part in the design and manufacture of that car. Where does KPIT fit in?
Leading automotive magazines used to, and perhaps still do, publish a blow up of a car's picture every few, editions, and they would show which part came from which supplier. So steering came from a particular supplier, and then infotainment came from somebody, instrument cluster came from somebody, and the traditional development process was like that. So car makers were primarily system integrators, and the suppliers brought in multiple dedicated one function only systems that would be built to the car maker's specification. So KPIT actually found its growth in that space. Our reputation is that of an automotive embedded software developer, provider of solutions and services. And as the suppliers would create these, one function or multifunction systems, we would engage with them as well as some of the OEMs in building that software. And there would be either a software development activity going on where we would take the features and build that software, test it out, and deliver to the supplier. The supplier would then integrate that into their hardware integration, deliver to the car maker. Car maker has their own cycle of full integrated system, system test, and then that will go to production and launch. Over time, and by that I mean in the last, I want to say about 10 years, the balance is shifting. So more and more of the software portion of this activity is being brought in-house by the car makers, the OEMs as we call them. And with that transition, what is now starting to happen is a pretty significant shift in how the software integration with third-party hardware is happening. And that's where the standardization is coming in. So as we've been a automotive company for more than 20 years and very well reputed for providing both solutions and services in multiple subsystems of the car. So we had expertise in powertrain, body chassis, of course, infotainment, diagnostics, automotive architecture, AutoSAR as we call it. But it's now all coming together. And as car makers are building this software more and more in-house, there's an element of integration that is now required at a scale which has not been seen before. And so our traditional role of providing software to a set of requirements, testing it out and delivering, very at a certain quality, that is changing to a very loosely defined set of variables that are constantly changing. And OEM is defining the requirements of what car they want to launch in parallel with the development of those requirements, which are in parallel with the multiple software components that are coming from a variety of outside suppliers who are also looking to launch their latest software component versions. And so those components are also in development, and the OEMs need to cram this whole development cycle from traditional 3 years to 18 months to even 6 months at a feature level. That's causing tremendous I want to say that's causing that's really galvanizing how it's done. And so KPIT is really emerging as a a player with the software integration capability, um, with the knowledge and domain expertise of each of those subsystems, and being able to run a software factory, if you will, that is bringing all of these variables into a common baseline software factory and delivering it as the production happens. So it's very interesting how our role has changed, and that's going to be our positioning as a software integrator as the industry evolves into these new connected autonomous and electric vehicles.
It is very interesting. And there was a potential there during this shift that a company like KPIT could have been sort of disintermediated, or, as the OEMs increased their numbers of software developers and their ability to develop software, we could have seen KPIT have their role shrink. Instead, it's shifted. I wonder if you could give us sort of an example from maybe a current car that's in development, and where you add value to that, and some of the cool features that maybe you're helping bring to life.
So I can think of a major OEM program we launched, or the OEM launched, for an infotainment system that used our platform, but also used us as a software integrator. So this was a very unique case where this would be a platform that would go into powering more than 3 million vehicles in their infotainment system. This would use our own Linux-based infotainment platform, which over time we have migrated to a full e-cockpit platform that can drive multiple displays. It had, as I said earlier, variety of varying OEM requirements. There was a certain baseline which ran into thousands of pages, but as the rest of the world around us is changing, especially the smartphone experience, these requirements kept updating. And there was a hardware manufacturer, which was the tier 1 supplier, as we call it, but there was also an independent set of software providers. So somebody was providing the echo cancellation noise reduction, somebody was providing a Bluetooth stack, somebody else was providing an over-the-air update stack. And those things work really well in isolation, but their implementation on a particular platform for that OEM's requirement is a distance that has to be traveled for every single program every time. And so KPIT came in as a software integrator. So not only did we have our own core platform, but we actually ran the baseline software across multiple geographies worldwide, across multiple SOPs or start of production dates, and actually integrated on a weekly basis, then on a monthly basis, an upgraded set of software versions that is getting validated in parallel as this software is getting developed. So it's a very, very dynamic process. The science part of it is easy to understand and easy to replicate. You can get the right tools, get the right DevOps and other practices that large companies use. The art portion of it is where KPIT shines. That that cannot be accelerated. That's just years and years of doing it and knowing what's the right validation methodology, at what granularity do you do what. So eventually this program actually went in production. At the time of launch, it was the OEM's, I think it was the highest quality program at launch. Actually, OEMs have seen that as the software variants and the components and the requirement and the speed of it is all changing and coming together, they need a software tier one, if you will, that's sitting next to them, that is bringing all the software practices, the best practices of software development at large scale and at automotive grade. And so KPIT is actually, we are seeing tremendous growth in that part of our business now.
Well, you've given me an appreciation of how complex the process is. And we just see it in the production vehicle that comes out, and it's beautiful and it does all of these things that we wanted our cars to do for so long. What is the role of the software platforms? You're obviously very familiar with QNX. You're very familiar with BlackBerry Ivy, with Linux, with all of the different platforms that the OEMs are using in their vehicles. What do you see as some of the major trends at that level in the cars of the future?
One of the trends and requirements of this whole software-defined vehicle movement is the ability to run applications and services both at the edge, which is on the vehicle, but also on the cloud. And there are certain distinct benefits to that. Most importantly, portability of applications, which can speed up product development and so on, but also real-time health monitoring of the vehicles, as well as providing new content, services, and applications that are not possible today, but can be possible because now a real-time version of that car is available on the cloud for a developer. So there's actually BlackBerry is hitting a lot of right notes with this IV initiative. The major block today in pulling off something like that is that the down to the car sensors, tire pressure monitoring or what have you, by OEM, by supplier, by program, and by geography, there are just too many variants. There's no standardization. And there's more time spent in standardizing those data sources and their formats, and then exposing them to third-party developers than actually building the application itself. And even if that is done by a given car maker, car makers have tried app stores or equivalent approaches. They haven't been very successful so far. And what's happening with Ivy is it's the only initiative where there's an element of standardization across all of the sensors, across all of the types of car makers formats. So it kind of abstracts the developers and also the car makers from having to worry about car by car, program by program, variant by variant integration effort. Once that's there, the ultimate vision of making a car available to multiple third-party developers as a platform to launch new ideas, new use cases, new services, new applications, that's possible. That is accelerated. So I think it's coming in at a very interesting time in the industry. If anything, it will accelerate the adoption of car as a platform by the developer community. That has been a challenge in the past for the car industry, just because of the sheer volumes of phones versus cars. But an initiative like this will actually accelerate that, and it will take out a lot of challenges in the process.
Well, of course, I'm gratified to hear that, but it's also something that we feel very strongly about at BlackBerry. Another thing that is a foundation of this company is certainly safety is the number one priority, and security ranks up there very highly as well. Are these things that we need to continue to be concerned about and to prioritize?
Since BlackBerry provides the foundational components and it has a really good chance of pretty much defining the flavor of the system's safety and security as it goes in. And we frankly think BlackBerry's best days are ahead of it, because now is the time where, as multiple traditionally separate functions of a car are getting consolidated on a single, central compute, that need of the safety certification as well as isolation, um, and other related, especially functional safety related requirements, is extremely acute. And doing that right requires somebody actually developing their software to that safety certification. um, Simple example, if on this central compute, we have an e-cockpit platform today which does both instrument cluster, central infotainment head unit, and rear seat entertainment on a single SoC or system on chip. um, the instrument cluster is a safety critical piece of equipment in the car. If I'm trying to skip a song, I'm frustrated and it's not getting skipped, so I start uh, hitting the screen multiple times, and that actually hangs, let's say, the infotainment head unit. Traditionally this was an entirely separate system, it could reboot. With the consolidation on central compute, now things are different. Now one subsystem crashing or rebooting cannot affect the safety critical systems, such as the instrument cluster, which is supposed to show you all sorts of real-time data. And so now is the time where um, this is one element of it that is getting very critical. And of course, you and I read about cyber attacks. That's the other element. So yeah, I think this foundational software-defined vehicle view, a few things like updatability, adaptability, and so on were considered. But of course, with that, it's all under the umbrella of safety and security.
Well, speaking of that, so you're going to be in the market for a car for one of your young family members who's going to be climbing behind the wheel. What are some of the, let's talk features. What are some of the cool features that they're going to enjoy in their driving experience? And what are some of the things that, even as a parent, you wish were available today to help ensure their safety? That's the most important thing.
So interesting you ask that. Clearly, they want the latest features. Essentially, the thinking is onto, they want the driving experience, but they don't want to compromise on what they do outside of the car all day, and that's their favorite content and apps. So that's the view that they are taking. As a parent, I'm just looking at the safety as a foremost feature. So I think in terms of what you are going to see, I think in the next 5 to 10 years, you're going to see an extreme refinement in how things come together. So we may get new content, apps, and features, and that may be possible. But today, it's an overload. It's a cognitive overload, even with the best infotainment systems. And sometimes I have an old car and I have a new car, and sometimes I drive the old car just for the fun of it. And I think the cognitive overload is a real deal. So a lot of that being taken over by well done voice systems and AI around that is going to be a major change. And today it's there. It's better than it was yesterday. It's still not at the level where it can go. So I think that's going to be a major change we're going to see. The other thing, which is a little bit far away, is 5G and eventually 6G type. So low latency communication between vehicles and infrastructure. So that's something that's going to come. It's a little bit far out today. On the safety side, of course, the level 3 ADAS is, those functions are starting to come in most mainstream vehicles. So that will only increase. I do think that, from an autonomous standpoint, she's not thinking of that today. But until people really experience how good that is, today a very small portion of the market has actually seen how it feels and how comfortable it is. So I think once that becomes mainstream, we'll be able to see how that evolves.
Bhaskar, Tell me about some of the recent engagements that you've had, some of the technologies that your team has been able to bring to market that you're particularly excited about.
I can think of one example where we built a very interesting product as a software framework that would let car makers uh, bring in third party, we call it nomadic devices, so occupants devices into the car. So we call the product Connect, and we actually have launched it with a car maker now, and that car maker is using it for letting kids in the back use their phones to do remote control of music, navigation, send an address to car, um, do family jukebox, so all the occupants can send their favorite song, and essentially, family trip. uh, it works seamlessly. What went behind that is, one of the cool things about KPIT is our core team is very passionate about these user experiences in the car, and we've done a long set of solutions and ideation that we do, and we just go ahead and build it. And this was one such example. And in order to do that, we actually built a many to many platform that basically brings many devices of not consistent. It could be um, a phone, a tablet, a garage door opener, and what have you, all sorts of heterogeneous devices, but integrate them with the car in a very homogeneous single API type fashion. It was very, very versatile solution. Um, to push the limit on that, we actually went ahead and built an in-car gaming experience. So we brought in a game studio. Essentially, if once you have a secure point-to-point way to exchange data between the car and a third-party device, you could stretch the limit. So that's what we wanted to do. So essentially, uh, and this is a new kind of group of use cases that are starting to come on the horizon now, which is customers or cars occupants bringing their own mobile devices, or we see almost even virtual reality headsets that are integrating with the car through a platform like ours. And at that point, based on the real time braking, accelerating, cornering that perhaps your dad is doing, you could be a kid in the back playing a game, and the parameters in the game are affected in real time. So that's something that we proved out. It didn't reach production yet. We are continuing to do many things around that. So that's an example of a use case that we've actually launched. The remote control piece is already in production for a few years now, and very, very appreciated by both users of the drivers as well as the passengers.
It's come so far from the games we played in the car as a child, looking for out-of-state license plates, or I Spy with My Little Eye, or some people remember Mad Libs and these other games, to anything to entertain the children and keep the parents' blood pressure down, right?
Yeah, one of the features we built on similar lines was actually taking a feed from the camera in the car, but actually feeding it wirelessly through to the phone itself. So you could see what the car, or the rear seat passengers can see what's being seen in the back. There's another one that we built around it where the instrument clusters, the speed and the gauges, they actually get animated, and the real time replication of that on a phone. Because once you have, like I said earlier, a secure way to exchange data between the car and a device, you can do wonders. And so that's what we built, and some of that got launched in production. It was very exciting.
That is very cool. You also, it kind of makes me think about, as cars become connected to each other and as they become connected to infrastructure, we have all of these smart devices. You might be playing games with people in the next car, or somebody heading the other way on the road. That could be really exciting new capabilities that we can't even dream of today. Perhaps your team can.
So our industry calls that the V2X, right? Vehicle to everything. And that's going to open up an entirely new gamut of things, not just, these more consumer centric features or, fun centric features, but uh, by the time, let's imagine an autonomous environment where multiple autonomous cars are there that are communicating, and now you have a particular situation where a car, a child, and a deer, they all kind of cross at the same time, some unique situation like that. And that's new learning for the algorithms. So now that data or the learning from that needs to go back to the model that's running on the cloud, and there's that additional learning there, and now that needs to be deployed to all the cars. So you have uplink with low latency that's required, which 5Gs and such technologies will enable. And then you'll need over the air updates, a downlink that is actually making that learning as part of all the entire fleet, that next time encounters that scenario knows how to handle. And of course, extension of that is vehicle to vehicle communication and then vehicle to infrastructure communication. So those things are going to expand the possibilities of or the realm of possibilities significantly more. So even more need for software integration.
Bhaskar, the cloud is playing an increasingly important role in the development of new cars, new features. How do you think that's progressing, and what are some of the areas where it's going to have the biggest impact on car design and the delivery of these exciting new experiences?
So cloud's bringing an interesting element. By itself, delivering services from the cloud to the car hasn't been new. That's been around through telematics for a while. It was on-premise systems. Now we have very large public cloud providers, and they are expanding their infrastructure at breakneck speed. And with that, what's happening is not only delivery of these services in real time and capturing data has become easier, but they are bringing the true benefit of cloud, which is scalability, elasticity, all of those things to product development side as well. So one of the major trends in this is virtual validation. Car makers, with the amount of software that's coming in and the amount of the sheer scale of it, has reached a point where if they want to shrink the cycle time of development from requirements to launch, um, they cannot wait on first getting the chip makers to design the right chips, then the tier one suppliers building hardware prototype, then testing that, and then waiting 6 months later finding out that there are these issues, and the old sequential product development, they cannot afford to go there. So now what's happening is the entire ECU, as we call it, or at least at a functional level, is getting virtualized, and that's being hosted in the cloud. So with that, you can actually remove dependence on hardware availability and test rigs availability, and make that whole development process global. You can go where the talent is, put it all on cloud, and parallel development, thousands of engineers plugging into one single platform, building an entire vehicle's unified software, that has become a reality now. It's a new trend. It is happening. OEMs are making an investment, but now we are seeing something that is unprecedented. So cloud is enabling that. The other piece cloud is enabling is the services that are getting delivered. So what you said, having a replica of the car in real time, that's been tried out in manufacturing under the digital twin terminology. But for cars with a dynamic system with so many more variables, it's going to be very interesting. And without cloud based data collection and intelligence, I guess, generation with AI and distributing that, it's just not possible to give that experience. So I think cloud is making a very, very fundamental change. Initially, people thought it was primarily about delivering services, but it's making a very big change on the product development side as well, especially in software defined vehicle and other connected autonomous pieces.
we've talked about these new platforms and capabilities and the ability of operating system and middleware to take out some of the granularity of bringing new features to life in cars. What are some of the obstacles? What are some of the sticking points with the auto manufacturers? A part of it perhaps is build it versus buy it. Do they want to do it all internally? Do they trust a third party to come in? Will that perhaps erode their ability to make their cars distinctive and differentiate them in the market? What kind of feedback are you getting from manufacturers?
So I think a couple of things we are seeing from car makers. There's a very strong desire to take greater control of the entire software process as well as software components in the car. So that's writing on the wall. That's an irreversible trend. Those car makers that can invest and build thousands of engineers worth of teams for doing the software are already doing so. And those that aren't are already on their way to partner with others who can bring that. So that's an irreversible trend. In doing so, I think fundamentally what is coming in the way is the speed at which that can happen, because the some of the core technologies in automotive, those are very specific to automotive. They're not general IT, or it's hard to find that talent. So there's the apps and content cloud development, which is there, but the core engineering of it, if you take autonomous development, if you see the entire life cycle or the development cycle from data ingest to the modeling, training, and then simulation validation, this is a particular feature set. It's not general software, general IoT, general IT, in fact. And so one major trend is bringing the right amount of talent fast enough. The second challenge we are seeing is car makers saying that they are not still at where they would like to be in an integrated vehicle level validation cycle. What I mean by that is they have great integration and focused, software test validation frameworks as well as development methodologies for each subsystem in the traditional development cycle, right? So everybody in a global OEM will say, this part works, infotainment, this works great in our lab. With an integrated vehicle, we don't know, right? The brake systems, the chassis systems, the steering systems, and so on. And it is on the OEM, especially the teams that launch that software, it is down to them to really bring it all together and sign up for production worthiness of the software they are releasing. The number of releases are increasing. The complexity of software that's coming together is increasing. And the time to validate is even lesser. And so that's a challenge where, some new frameworks and new methodologies are coming. We have one ourselves. We have looked at these problems, hearing from the OEMs, we've looked at these problems multiple times. And as I said earlier, having gone through building those solutions, I do think that we are going to see some really step up in refinement of how things come together in the car experience in the coming years.
I'm excited to see that level of integration. And I gained a new appreciation of how difficult it is and the resources it's going to take as we turn the page to this new chapter in automotive history, which I think we're very lucky to be here to have a front row seat for. And Bhaskar, I want to thank you very much for giving us this deep dive into what KPIT does, how cars come together, and how you're able to deliver these next generation experiences that we're so excited about.
Thank you for having me. This was very exciting, and we look forward to working together.
Well, that's the end of our episode for today, but if you'd like to get more information on the topics or our guest, check out blackberry.com/podcast. Get in. The Connected Vehicle Podcast from BlackBerry is available wherever you get your podcasts, and don't forget to subscribe to keep up to date with our latest episodes.